In this video, we are going to talk about physical quantities and units. Now, what are physical quantities? Now, physical quantities are those quantities which can be measured by an instrument and by means of which we can describe the laws of physics. Now, meaning it is not just measurements, like if I write a number 400, this is just 400, just a number, ordinary number. Now, not just ordinary number, but we must have a unit, so we must describe it with the law of physics. So that is, this is 400 kilometer. So for a physical quantity must include a numerical value and units. Here 400 is numerical value while kilogram is units. So what are the examples of physical quantity? Examples of physical quantities are, so let's say, length, let's say velocity, acceleration, force, time, pressure, mass, density. Now all these examples are physical quantity, etc. Now all these now can be measured and it will have a numerical value and units. That is, I can say 10 meter per second square, so it is a physical quantity because it will have a numerical value and units. So what are the these are the types of physical quantities, just not all but few. So now, what can you say about units? So we have physical quantities and units. Now what can you say about units? Now units, now we have already said that if a substance should have a numerical value, then it should have a unit. Now the quantities are measured in terms of units, so for you to understand better now, that is, physical quantities are measured in terms of units. So that is, the unit of measurements for length, the unit of measurements of length can be meter, kilometer, centimeter, millimeter, and etc. In short, we can also measure lengths in inches, feet, yard, miles, etc. So that is unit of measurements of length. Now unit of measurement of mass. Unit of measurement of mass, it can be kilogram, gram, ton, etc. And unit of measurement of time. Unit of measurement of time can be second, minutes, hours, etc. So all these one now, they are units. So now we have types of physical quantities. So I'll describe them. I'll talk about three types, just in brief. Three types of physical quantities. So let me clear the canvas. Now types of physical quantities. We have one, fundamental quantity. Fundamental quantity. This is one type of physical quantity. So you can say fundamental quantity or basic quantity. You can jot all this down. So now, what are fundamental, or what is a fundamental quantity? Now, fundamental quantity or basic quantities are those quantities that stand alone. That is, they don't depend on any other quantity. That is, other quantity are derived from them. For example, example of fundamental, we have 7 fundamental quantities. So general conference on weight and measures, they choose 7 physical quantities as basic or fundamental, and those 7 quantities are, so examples of fundamental now. 1, they are length, which is measured in meter. B, that is 2, time, which is measured in second. 3, C, so mass, which is measured in kilogram. 4, we have temperature, which is measured in Kelvin or degree Celsius. 5, electric, can say electrical current, which is measured in amps or ampere. F, luminous intensity, luminous intensity, that is CD, candela. G, amount of substance, amount of substance, that is mole. Now these 7 quantities, 1, 2, 3, 4, 5, 6, 7, they are the basic quantity or the fundamental quantity. That is, they stand alone. You can't combine them with any other quantity. That is, if you look at length, it's just in meter. Look at time, is in second. Look at mass, is in kilogram. So that is, they stand alone. Now every other quantities are derived from these quantities, so that's why we choose them as the basic quantity. So you can define fundamental quantities are those quantities that stand alone. That is, they don't depend on any other quantities, or other quantities are derived from them. So with all this, we can now say derived, number 2, derived quantity. But before we say derived quantity, let's talk about system international, that is SI units. So let me clear this. So these ones are fundamental quantity. So now system international, that is SI units. That means system internationally, SI units. Now what is system internationally SI units, or simply SI units? So instead of saying system international, then you can say SI. Now what is SI units? So these are the units that are internationally accepted by scientists as standard unit of measurement. So every quantity has more than one unit of measurement. For example, length has more than one unit of measurement. So length can be in centimeter, meter, kilometer, it is a millimeter, and like that. So now, since every quantity has more than one unit of measurement, that is, for each quantity there are smaller units, meaning out of those units there are some that are small and there are some that are big. So however, now for uniformity, that is, we want just one. We can't say because some are small and some are big. So for uniformity, the international system of measurements, so that is the SI, generally accepted and agreed on some units as standard units of measurement. So these units are called the SI units. So when the body agreed on a certain unit, then they are called the SI units. That means all those examples I gave you for the fundamental quantities are called SI units because they stand alone and is unique. So for example, unit of time are second, minutes, hours. But the SI unit of time, the SI units of time is second. That is the most acceptable, is second, so that everything will rhyme. That's why if you solve question in physics, we say change all the units, change it back to second. So that is the generally accepted units. So, and again, we can talk about derived quantity now. So just take notes. So all those fundamental are the SI units because they agree on them, and we are using all those ones till now. So derived quantity. Now, what are derived quantities? Now, these are the quantities that are obtained from a simple combination of the fundamental quantities. That is, they are derived from the fundamental quantities. So, if you say velocity now, for example, the unit is meter per second. You see, meter is fundamental, second is fundamental. So when you combine fundamental units, then you can have a derived unit. So the derived unit, we have a quantity for it also, that is velocity. Now that reminds me, then as we talk about fundamental quantity, then we should talk about fundamental units. Now, what is fundamental unit? It's very easy. They are simply the unit of fundamental quantity. That is, fundamental quantity is length. Now, fundamental unit will be meter. So that means fundamental units are the units of fundamental quantity, just like that. Or they are the units that does not depend on any other units. That is, they stand alone. So likewise, derived units also, they are the units of the derived quantity. That is, they are the simple combination of the fundamental units, just like we say meter per second. So that is derived units. Why the quantity that gave us that is velocity. Now, but we can derive units by ourselves of any quantity. Now let's take the physical quantity, density. Let's derive the unit for density. Now, density, what is the formula for density? Density is mass over volume. And what is the unit of mass? Mass is in kilogram. What's the unit of volume? Volume is meter cube. That means the unit of density is kilogram per meter cube. Now in physics, this divide is what we turn to the slash. So, or according to law of indices, I can decide to say this is kilogram, then m raised to power minus 3. As we know that in law of indices, a raised to power minus 1 is 1 over a. So that means this is the units for density, kilogram per meter cube. So that is the units for density. Now let's take the physical quantity force. The physical quantity force. Now, what is force? Force is mass times acceleration. Now, what's the units for mass? Mass is in kilogram. Acceleration is meter per second square. That means the unit for force is kilogram meter per second square, which is named after the scientist, that is Newton. We use n. So that's how we can derive. You will notice that all these units, kilogram is fundamental, meter is fundamental, second is fundamental. By the time we combine all the fundamental, then this is fundamental units. But what gives us the units is quantity, force. So you should know the difference between quantity and unit. So force is a quantity, while all these ones are units. So like that. So the next thing we need to talk about, we need to talk about measurements, but I would like to do measurements in another video. So let's recall everything we've learned. We talk about physical quantity first. We talk about physical quantities. We said they are the quantities which can be measured by an instrument, and by means of which we can describe the laws of physics. And we say physical quantities must have a numerical value and units. That makes it related to physics with units. If you write ordinary number, we can just say it's just a number. So now we say we have types of physical quantity. We said we have fundamental and we have derived. Now fundamental quantities are those quantities that does not depend on any other quantity. That is, they stand alone. That is, their examples. We give all the examples and their units. Also, derived quantity are the simple combination of the fundamental quantity. So that is, they depend on fundamental quantity. We also give examples. We have many examples for derived. So far, we can just combine any fundamental to get derived. Now, I said I'll talk about 3. So the third one I'll just talk about in the types is supplementary. Supplementary quantity. Now, beside our 7 fundamental quantities, 2 supplementary quantities are also defined. That is, they are plane angle, the angle between one plane angle, the angle between 2 lines, and also solid angle. So this is supplementary. So but the one we focus on based on our own syllabus is fundamental quantity and derived quantity. Now if I say give examples of physical quantities that you know. So physical quantities are categorized types of physical quantity. We have fundamental quantity, derived quantity, supplementary quantity. But examples of physical quantity can have length, velocity, force, density, mass, etc. So now in the next video I would like to do measurements there. So this video contains physical quantities and units. So thank you.